All right, so friendly reminder, anytime that I am absent, you always have stuff to work on. I would never leave you with just like a free day or anything like that. Whether you actually do the work or not, it's entirely up to you. Some of you care about your grades and what you're going to do after high school. Some of you don't, or think it doesn't matter. Whatever. It's all on you to make sure it gets done. The policy is that grades are updated within 7 days of submission. So like, if you want your grades updated sooner, then turn in your stuff sooner. I don't know what to tell you. Believe it or not, I don't sit at my computer and wait for you to turn stuff in. Grading is a part of my job, but so are like many other parts, like lesson planning, like actually teaching you. Sometimes it takes the whole hour to teach you and I don't have any time to work on anything else. So be patient. I'm still grading those retakes. I think those are a higher priority than whatever late work you had from weeks ago. All right, if you can take, I don't know, 2 weeks to turn in an assignment, then I can take 1 week to grade it. Okay, just because you rush me doesn't necessarily mean I'm going to drop whatever I'm doing to update that grade. If you don't want missings in there, turn them in on time, like the day that they're assigned. Okay, and really right now you should only be working on stuff from this unit. Stuff from the last unit, I don't have to accept anymore. And I'm actually going to stop thinking those ones to the grade level. So if you want to like last minute get those ones turned in, great. They're just going to stay whatever score they're at after like today. All right. So any questions on that? All right. So I'll be putting in those missing for yesterday's work here shortly. It was a note sheet, so you watched the video, and a practice. Make sure you know which is which. The note sheet, we usually don't do every single problem. So you should have watched the video and done the problems that we did on there, not necessarily every single one. And if you paid attention to the instructions for the practice, it was just evens or odds. So really just 10 questions from what you just learned. So this is the practice. Earlier, I had someone doing all the problems on the note sheet, which is not the same thing. All right, this one was the practice that goes into the specific link in Schoology. So I'll show you. Okay, so here's this week's folder. The note sheet goes in here. And you all need to know how to upload stuff into Schoology. You guys need to be better with technology. And look, here's all the people that follow directions, by the way. So still missing quite a bunch. So this is where your note sheet goes. And here's all the instructions for it. Here's the video that you were supposed to watch. And there's your note sheet. Okay, so no reason that shouldn't be turned in by now. You had an hour to do it yesterday. What else? So that's for the note sheet. The practice goes into the other link. This one that says practice. And then that, so only have a few submissions from you guys, not good. That is viewable under this rubric. Okay, so again, that's what the practice looks like in case you're confused. Just evens or odds, your choice. That should be just 10 problems, completely doable and turned in by today. Well, really, it should have been yesterday, but you had an hour to work on it yesterday. So any questions on that? All right, so that should be an easy points because I'm grading that one on completion and work shown versus like accuracy, like most of your other stuff is graded on. I do upload the note sheets after the sub day because I really do want you to actually watch the video and learn from that experience. But if you just need to get like your notes done or you want to do the rest of the problems and see if you get them right, here's like the fully completed note sheet. This is not the practice. This is the notes. Okay, so questions on that? All right, if you were absent yesterday and want the papers, you can come ask me for them now or line up and I'll give them to you. Otherwise, I always put the responsibility back on you. I make you like go into Schoology and copy them on your own paper or on your own practice paper. But if you ask for them, I'll give them to you. Yeah, I used to keep an absent folder for all my absent students, but I just have way too many students to be keeping track of that. So that's why I put everything in Schoology so that you can access it from anywhere, anytime. All right, so now back to the notice and wonder. Last time we picked a reporter, it was whoever was closest to the door. This time it'll be whoever is farthest. And you guys should have already talked about it, so even if you didn't notice or wonder something, you could steal what someone in your group already said. Okay? So table 2, tell me something that you noticed. So whoever's farthest from the door, that looks like Alex. It could be something that you noticed or that someone in your table noticed. Maybe that's talking about. Okay, so in the first table, we noticed that the Y's are going up by 5. All right. Table 4, what is something that you noticed? So it increases and decreases. Is it by like a consistent amount? Okay, so it does say that there is a pattern, just the pattern isn't really sweet, right? Because it's going up by 3 here, then it goes down by 1, then it goes down by 5, then it goes down by 9. So it's not a clear pattern, but there definitely is, because it says, look at the pattern. So that's fine if we don't know it by now, that's something we noticed. Table 6, what's something else you noticed? All the X's in each table go up by 1. All right, so that's a good notice. Table 8. Can you give me another notice? Each Y value starts differently in every single table. So good. Let's see. I'll now take volunteers for any notices that we haven't said yet. Brianna? Okay, so it's the only one that has a negative number at all. The rest of them don't have negatives in either column. Hayden? Okay, so in this one, we're multiplying by 2 each time. All right, any other notices? Brian? It does what? 8, 9, 10, 11. You want to take that back? Yeah. Okay. Any other notices, Brian?
Third one, minus like 4, minus 1, and then that would take the word minus 5, the word minus 5.
Okay. Because to me, this is going up by 30.
4.
I don't know how to write that down. But you guys are saying something, I don't know how to phrase it for everyone else to see. Because to me, it's going up by 3 and then minus 1.
Like basically the numbers that are
Oh. Okay, you're saying these numbers have a pattern. Okay, and what's the pattern? Going down by 4 each time?
Yeah.
Okay, interesting. I didn't notice that one. That's why I was so confused. Good. Can someone tell me what the first table is an example of? What type of function? Linear, good. So if you're adding the same amount each time or subtracting, that's linear. It would give you a straight line. what would the middle table look like? Exponential, good, because it's doing what each time? Good, when you multiply each time, exponential. This one, we're actually learning about this unit. You guys may not know the name of it yet. And you guys may not even be able to see the shape of it yet. You could, because we know like this one will be a straight line. We know this one will, since it's increasing, look something like that. But the last one is a little bit unclear because it's new to us. Question, Brian? Not necessarily. But, so let's see. So what I'm doing right now is plotting the points in Desmos. So Desmos can put stuff on a coordinate plane for you. And you just have to write it in coordinate form. And is it clear to see what the pattern is? No. What you will see once we formally introduce you to what the pattern is, because I can see it because I know what it is. This is essentially making like a U shape. So in this unit, it's called Introduction to Quadratic Functions. We're going to look at graphs that have a U shape. So it either goes downward like a frown or upward like a smile. But those are now the new graphs that we're going to be looking at. Okay, I probably wasn't supposed to tell you that yet, but I just think it's kind of cool. Like you guys found some patterns in there. You can kind of see what it's creating, but we'll learn more about them in this unit. Okay, so good warm up. We didn't talk about any wonders, but I'm sure you're wondering like, well, what is the third one called? What is the pattern? Like if you couldn't find the pattern, there's probably a bunch of wonders that you could have had. But good. For time purposes, we'll keep it moving. Now, these next two activities I think are good for like our state testing. All right, so we have Noah has 50 meters of fencing to completely enclose a rectangular garden in the backyard. First, they want you to draw some possible diagrams of Noah's garden, label the length and width of each rectangle, and then it wants you to find the length and width of a rectangle that would produce the largest possible area. Okay, so when we're talking about 50 meters of fencing, does that go like around it? Does it go in it? How does that describe what's going on? So fencing goes around. What type of measurement is around a shape? No, area is within a shape. Around a shape would be perimeter. So we're essentially saying that we want the perimeter to equal 50. So that's a requirement. So you're also trying to find what two numbers can have a perimeter of 50, but also give you the largest possible area. So perimeter, you add all the sides in case you don't know. Okay, write that somewhere if you don't know. If you already know, then maybe you don't need to write it. So perimeter of any shape, you add all the sides. How do you find the area of something? Good, it depends on what shape. We're talking about a rectangle. So for a rectangle, it is the length times the width. What's unique about rectangles? Or can someone describe a rectangle to me?
They have two equal sides. No, they have four. Like two sides along the.
So good, I heard a few good things. Some other people said some stuff at the same time too. They have two pairs of equal sides. So like the ones that face each other are equal in length. And then someone else said that they have two sets of parallel lines, which is also true. Okay, so knowing that a rectangle, do they have to have it where all sides are the same? No, could they have it where all sides are the same? Technically, yes. So like a square can be a rectangle, but a rectangle cannot be a square. All right, that's preparing you for geometry. So play around with some numbers for your length and your width. That when you do the perimeter, add up to 50. But when you do the area, you get the largest possible area. And you could put those dimensions in here. All right, but the perimeter for sure has to be 50, so if you want to add like a column, that's fine. So in your group, try finding what combination of numbers to give me the largest possible area, but still have a perimeter of 50. We'll kind of make it a competition. Whoever can find the largest area, but still a perimeter of 50 can pick from the pie chart. Okay, so we'll give you 2.5 minutes to play around with the numbers and see if you can find the one with the largest possible area. All right, and actually I think I'll flip that. So first, raise your hand if you think you found the largest possible area that still has a perimeter of 50. All right, just one group so far. Landon?
15 by 10.
Okay, so
Shorter.
that would give me an area of what class? Because if it's length times width, 15 times 10 is good. And does that still give me a perimeter of 50? All right, so the diagrams can go under your number one. But yeah, we could do 15, 15, 10, 10, add those all together. You have 30 plus 20, which is 50. So that works. Is it the one with the largest possible area? Did anyone find one that they think is better? Allison or Ryan's group? 18 times 7. Okay, so let's see if that gives us a perimeter of, what do you call it, 50. So I know 7 plus 7 is 14, 18 plus 18 is 36. Add them up. You do get 50, so it does meet the 50 requirement. What is the length times width for that? $126. All right, I'll just confirm that right now. Still not the largest area, the 150 would be bigger. The 18 times 7 is 126, so you guys should probably add that to your table if you don't have that. Any other possible, because there's actually, I have an answer in the book that is bigger than what is up there. Does anyone have it, or should just Landon's group one? All right, there is one with a greater possible area. Ryan?
13 times 12.
13 times 12. All right, let's see what area that is. So 13 times 12 is 156. Let me see if that adds up to 50. So 4, 5, 6, 7, 8, 9, 10. Yep, that adds up to 50. So far Ryan's group is in the lead, so that's table 2. Anyone else? There's even one that's greater than that. So if you think you know which one can produce an even larger area than that, speak now or forever hold your peace. One. Going twice,
Wait,
what, you think you guys have it?
I just can't work this one out. We're going to talk about that.
All right, in the meantime, so it's all right if your area isn't the largest, but with another combination that has an area or not necessarily, that has a perimeter of 50. 20 times 5. So yeah, that would give me a perimeter of 50, that area would be 100. All right, Landon's group, last call. Okay, so then Ryan's group, you can go pick from the prize box, it's on the back table if you like. They were the ones that came the closest. There is a better answer, no one said it. Maybe you have it, but you just didn't want to say it. And it is 12.5 times 12.5. Why did you think that wouldn't be right?
I don't know, I thought it wasn't equal to 50, so I wasn't working it out. I just kept thinking it wasn't equal to 50, so I was.
Well, remember, guys,
Let me do it as well. So now you calculate it.
all right, remember, guys, squares can be rectangles, but rectangles cannot be squares. Okay, squares have more like criteria. Squares have more criteria for what they have to be, rectangles have less. So even though a square has it where all the sides are the same, they're still technically rectangles, because for a rectangle, you just need to have the opposite sides be equal, the sides be parallel, and 4 right angles, which a square has. It's just a square also has all sides the same, but it can still be a rectangle, it's not like. All right, so questions on that? All right, but either way, main point of this, because you will see this on your homework, is how to play around with numbers so that you get a certain perimeter and a certain area. Can you guys tell me, there's also a pattern between this? Can you tell me, like, if you see that pattern?
They're all equal to 45.
Good, so if you add the length and width, they all equal 25. All right, so that could be another way to find numbers if you wanted to. So like I could do 24 and 1. And that'll still give me a perimeter of 25. Area would be 24. I could do 11 and 14. And that'll still give me a perimeter of 50 because it's following that pattern of adding to 25. Questions on that? All right, now the next part. So we are going to plot some values for the length and area of the garden on the coordinate plane. When you guys plot stuff, what are coordinates always in the format of? X and Y. Julian, I'm ignoring you for a reason. I'm in the middle of teaching. Maybe you should pay attention. All right, so what is the X representing according to this? The area. What is on the x-axis? The length. So you're going to look at your table that you made and pull out the length as your x. And then what are you pairing it with for your y? Nope. What does it say on the y-axis? Area. Okay, so each coordinate goes in the order length, comma, area, and so forth. So you're gonna plot some that we made from that table we just filled out, or whatever table you filled out. You're gonna notice something about the points, hopefully. Real quick, here's like an example that can kind of help you with number 1 if you're so confused. The points 3, 66. So 3 on the x would be here, 66 on the y would be about there. and 2266. Each represents the length and area of the garden, so it goes length, comma, area. Plot these 2 points. What do these points mean? All right, well, if the 3 is in the length part, then that means the length is what? So what is that 3 representing? The length. What is the 66 representing? The area. So if area is length times width, so like area 66, length is 3. What must the W be? I know it's the width, but what value would it be if its area is 66? 22, good. If you couldn't figure that out by looking at it, do your inverse operation. Opposite of multiplying is whatever you do on one side of the equal sign. And what's 66 divided by 3? So you could solve it algebraically. So that's what it means. 3 is the length, 66 is the area. What about this 22, comma 66? That means 22 is the, but if it's in the X spot, it is now the length. So 22 going in for the length, and then 66 going in for what? The area. If that's the case, then what must W be? No, what's 66 divided by 22? 3. Is it a rule that like the length always has to be longer than the width? No, it is not a rule. So what this is saying is that essentially these are part of the same rectangle. I could go back to my coordinates and flip-flop all the lengths and width and have other things to plot onto this graph. All right, so I could do 10, 15, 150, and now I'm plotting 15, comma 150 and 10, comma 150. Does that make sense? Okay, so then now answer number 1, plot some points from that table we filled out. And then once you've done that, see if there's a pattern, and then answer number 4. Okay, I'll give you 3 minutes. All right, so table 1, can you tell me a coordinate that you plotted? Right, so 13 would be here-ish, 156 here-ish. See if that was one from our table. All right, and it is. So remember, these go in the order length, comma, area. That's what it said on the graph. So the x-axis is your length, and that the y is your area. Could I also plot 12, comma 156? If I wanted to? Yeah, I could basically flip-flop these, right? So there's no rule that the length has to be longer or something like that. So I could also have 12, comma, so probably here, 156, so like right next to it. Any others? Table 2, what's the coordinate that we plotted? 12 and 100. Let's see. So what was your width for that one? Okay, so I don't think that would work because, oh, it's 20 and 100. Okay, there we go. Let me go back. That makes more sense. Because if I put it here, it kind of messes up that U-shaped pattern that I was getting. So we wanted to have a perimeter of 50. So then, yeah, we could do 20 and 100. If that's my length, what would be my width for that rectangle? Table 3, tell me. If 20 is my length and the perimeter is 50, what must my width be? 5, good. So if I decide to flip flop the length and the width, I could also plot this. And it looks like I plotted a little bit in the wrong spot. 20 and 100 is here. But are you noticing that if it's from the same rectangle, that they're like on the same Y? So they have the same area. Okay, so that's what we should be noticing, Ellie. Table 4 was the coordinate that we plotted.
Um,
18, 126 and 7, 126, I can also plot. So 18 would be here-ish, 126 would be about there, 7 about here, 126 about there. All right, now the one where it was the highest area, that 12.5, 12.5, I can plot that, right? And would I have 2 separate dots then? If I like flip flop the length and width? No, because it would be like right on top of each other. So that one I could only plot once, but I'm gonna plot that one too. And notice that it's also like the highest part of our graph. So 12.5 would be around here. And just a little bit above these, okay? So for what you're noticing, you could say that it makes like this kind of shape, which is important, or at least it will be later. Question out here? Okay, I'm almost done, so I'll help you in just a second. So number 4. It says, could the point 125 represent the length and area of the garden? Talk about that briefly with your group if you haven't already. Come to a agreement, because I'm gonna pull you in a second. All right, raise your hand if you think the answer to number 4 is yes. It can be the length and area of the garden. Raise your hand if you think no, it cannot be the length and area of the garden. All right, Peyton, why do you think no? Okay, so because the length is 1, the width would have to be 24 if we still want a perimeter of 50. That was the limitation on this. So your reasoning could be no, because the perimeter would be 52, not 50 like it said. Remember, those two numbers should add to 25, and that would not be it.
Ms. Medina? I do.
Yes, no problem, fine. Okay, so does that make sense, guys? Oh my god. All right. All right, that is it. Work on your practice.